Hi, this is John Mahar. I'm with Reset. We're a nonprofit organization that puts volunteer STEM professionals in schools to work with the students on science experiments and math activities. And we focus on hands-on because that gets children excited about STEM learning. We're usually in the classroom or working with a community organization such as the Girl Scouts. But given the virus situation, we're putting up on Tuesdays different activities that can be done at home with commonly found household items. I'm going to do this first part of this session first and then explain how to do it because it uses hot water that I've microwaved and I don't want it to get too cold before we proceed. So, take a small container, add 4 drops or so of food coloring, then add the some hot water, just a little bit. All you need is an eyedropper full amount. Then you put the eyedropper into the mixture of food coloring and hot water, and then you drip it very carefully into a cup of cold water and have the children observe where this colored water goes in the cup of cold water. So the observation is that it floats to the top. So the lesson here is that hot water has a lower density, liquid density, than cold water. Or depending on the age of the child, you can say it's just lighter than cold water. And this shows the experiment. The tricky part is you have to drip it very, very carefully. Put the eyedropper tip at the very surface of the water and very carefully squeeze the bulb because you want the water, the hot water, to go in without mixing. So you want to limit the amount of motion. So basically the premise is that heat causes atoms and molecules to expand. So there's more density in the cold water than in the hot water. When the molecules expand, they're further spread out and it's not as heavy. So that's the first part of this experiment, and you can also use salt water or reverse it and put the cold water, drip it into hot water. You have to be more careful with those, and it's not going to work quite as well because as the cold water and salt water, being more dense, sinks to the bottom of the cup, there's some mixing that occurs, so it's not quite as dramatic or differential as the hot water going to the top of the cold water. Second part of this experiment is about why things float and sink, physical solid objects. So in this experiment I use a baseball and a golf ball. And I have the children learn which one is heavier. And the way I'm doing this here is I have the golf ball in this sock and the hard ball in this sock. And this particular hanger has hooks, but if not, you're gonna have to tie a knot or somehow hang it. And you could also use a kitchen scale to compare the weights. So if you do use a kitchen scale, you'll find out that the baseball is about 3 times heavier than the golf ball. I like to use this because it shows kids how a balance scales works, and remind them of when they go to the doctor how they weigh them on the scales, and they use the weights to get things in balance and determine how much they weigh. So then if I remove these and I ask them to make a hypothesis about what makes things float and what makes things sink. And often they would say heavy things will sink and light things will float. So then I have them put the two balls in this tub of water and observe that the golf ball sinks while the hard ball floats. So the baseball, being the heavier object, floats, and the golf ball, being the lighter object, sinks. So there's something going on here besides just weight, and that has to do with the shape of the object, or depending on their age level, you can get into the density of a golf ball being higher than the density of a softball. Then I'll have them make a canoe out of aluminum foil. Many of the younger inner city children don't know what a canoe is, so I use this graphic that shows a picture of a canoe. And the way you make that is you take a piece of aluminum foil about 6 inches by 9 inches, and you fold it down the middle like such, and then at each end you fold in a small fold and then do a double. Whoops, there it goes. Do that at this end. And then you open it up to make a canoe-shaped object. Put it in the tub of water and then put the golf ball in it. And in the classroom I'll have the children see whose canoe floats the longest with the golf ball in it. But the lesson that we're going for here is that even though the golf ball by itself sinks in this tub of water, when it's in this canoe-like shape, it floats. And the lesson here is that the fact that it's in the canoe with air, the weight is distributed, the golf ball is heavier, the air is lighter, and the overall effect is that it's light enough to float, or the density is low enough to float. And then I talk to the children about tankers that come across the ocean carrying automobiles or oil, tankers in the case of oil, ships in the case of automobiles, and how heavy those objects are, but the shape of the boat is designed such that it will float even though it's carrying those very heavy objects. And it's a matter of what's the overall density of the material on the ship, and is it greater than the density of water or lighter than the density of water. That's our lesson for today. Tune in next Tuesday for another experiment on our Reset Tuesday sessions. Thank you.